Right, so this is the last video from this chapter. We're going to take care of some colligative properties. Now I'm going to jump to that first because boiling point and freezing point relate to how they respond when you add a solute is a colligative property. So a colligative property is a solution property that depends on the number of solute particles. So it's the quantity. It's how many particles there are. So when we made ice cream, we made it a little earlier this year than this particular point in our learning, is that colligative property, ice cream had that because a colligative property had a freezing point. What we did is we depressed the freezing point. So we made the freezing point go down. So with the ice cream, we made the freezing point go down by adding the salt to the ice, okay? So again, when we had ice, that's at 0 degrees Celsius. But what we did when we added the salt into the bag, that made that temperature go below 0, and then it was colder. And then when we let it melt a little bit, it surrounded it completely. And that's how you got that nice crystally ice cream. So again, the freezing point went down, or we call it a freezing point depression. So properties that depend on the quantity of solute particles called colligative properties. Like I mentioned already, boiling point and freezing point are both colligative properties, meaning not the actual points themselves, but what happens to them when they are in solution. So when we have a solution, here's the picture I want you to have in your head, and I may add this to the notes later, is that, okay, let's say it's water, all right? So you put water, you put something in water. It doesn't matter what it is, okay? Well, for instance, I'm sorry, let me just start out here, sorry. It boils at 100 degrees Celsius, so that's your boiling point, okay? And then we know at sea level, it will freeze at 0 degrees Celsius. That's your freezing point, okay? And so that is the range that this is a liquid. So we have liquid water. Now, when we add a solute to the situation, let's say we're cooking some noodles and we're going to add some salt because the salt prevents them from sticking as much. What happens, though, when I put this NaCl in here, the boiling point is going to raise. Let's just say it's 101.3. We're just going to make up a number right now. I don't really know. So this is the boiling point elevation, okay? We call it an elevation, and I think it's on the second page that we write all that out. But I'll get there, okay? But it's an elevation. I can spell it right, okay? It goes up like an elevator. I mean, the elevators go down too, but it's a rising of it, okay? But we call it a boiling point elevation. And then when we add that salt, it also lowers the freezing point. So the freezing point is a depression. Okay, we call it going down. All right. And so those are the technical terms for this. And that means, look at this. All the way through here, now this is salt water. Okay. And that salt water has a longer range as a liquid. So what do we do when we add a solute? We extend the range that something can be a liquid. All right. We do this when we add salt to icy roads. You guys all know this, hopefully, that when it is ready to ice or it gets really, really cold outside and we don't want our roads to have ice on them, we add salt to the road to lower that freezing point. So hopefully it won't melt. It'll stay as a liquid longer. So that freezing point is going down. Now there is a limit to how far that can go down. And a lot of now we've learned that we want it to stick to the surface, the salt, a little bit better. And they'll add like beet juice, or that's a really darkish color when people think their tires are rubbing off or something like that. Nope, it's just beet juice. Or in Wisconsin, they use cheese curds, all kinds of things like that. Some organic materials make it stickier. Antifreeze is also another good application of this. Energy coolants in your car. So it cools down your car. It's called ethylene glycol is the chemical composition of it. It's dissolved in water, of course, but when it does that, it raises the boiling point and lowers the freezing point. So it protects it both ways, so from overheating and from freezing. So it's a neat thing. Side note, dogs, it can poison, so make sure if you're leaking antifreeze, you always clean it up or get it fixed, of course. All right, so tomorrow we'll go through this in class to see if we did truly understand.